Yeah. Okay, so ignore that on the right. That's something we're doing in calculus. So does anybody have any last minute? Hopefully you've been doing these reviews. You're starting to get more comfortable. You're missing less stuff. But if, oh yeah. Does anybody have any questions? You're welcome to work on that last one. Based on what you said yesterday, I'm really hoping it's not a repeat of what we've already done. I have this sneaky suspicion it might be. Yes?
On number 11, there's like the one question about a flush. And then on the P, multiply by 2. Oh, wait.
Does that make sense?
Yes.
Okay. Yeah, I could have multiplied it by 4C1. That's me choosing which suit it would be.
24.
24. And what was this one titled?
Probability counting, not in the book.
Not in the book. Probability and counting. Okay. So probability and counting. I really don't like this not in the book thing. So used to having page numbers. So this probability and counting
Yes.
just says that what number?
24.
So 24, if I choose 13 cards, that one? This one?
Yes.
Okay. So what's the thing about this one that makes it, in my opinion, tricky, although I'm hoping you guys don't find it that tricky because we've talked so much about it, is you have no idea, or you have to count up all the different ways I can pick the kinds, right? And the key to this is you can't just say, and I think I've told you this a couple dozen times, but you can't just say, well, on my first 3 of a kind, which granted, that's going to be the 3 of a kind, I can't say there's 13 ways to do it. And then on my second 3 of a kind, I can't just say, well, now there's 12 kinds left, so there's 12 ways to do it. And on my, it said twice. So I can't do that because essentially saying that there's 13 ways to do that 3 of a kind and 12 ways to do that 3 of a kind, the 13 and 12 is really saying this. So the problem thinks if you do it this way, that the order in which you pick those kinds has an effect on the outcome. But clearly, picking something like 10, 10, 10, and then 7, 7, 7 is not any different than 7, 7, 7, and then 10, 10, 10, is it? And because that's no different, the order in which I choose them really doesn't affect the outcome. So I really need a 13C2. And a 13C2 is really not easy to do like this. You would have to do that, and then divide one of them by a 2 factorial. So what I do is instead of going 13, 12, I say, well, if I have the same number of each kind or each suit that I need, I'm going to go ahead and pick those kinds at once from the 13 and say 13C2. And that will cover this and this, the number of ways to do it. And that gives me 13 times 12 over 2 factorial when all said and done. So that's the number of ways I can choose the kinds of 3 of a kind, 3 of a kind, and also figures in how many ways I can pick those 3 kinds once I decide what the kinds are. That makes sense? And then you go to the 2 of a kind. That happens 3 times. So 2 of a kind, well, that part's easy to do. 4C2, 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 or 4C2 cubed. But I cannot think this way. I cannot say, well, I've already picked 2 of the kind, so there's 11 left. I can't say, well, there's 11 ways to do that one, 10 ways to do that one, 9 ways to do that one. Because if I say that, what am I really doing? 11P3, because that's what 11, 10, 9 is. And that would suggest that 2 of a kind, 2 of a kind, 2 of a kind, the order in which you pick them would affect the outcome, but that's not true. So because I'm picking the same number of each, instead of doing that separately, I just say, well, there's 11 kinds left. I'm picking 3 of those. So once I actually pick which kind I'm going to be arranging, I pick 2 of the first kind, 2 of the second kind, 2 of the third kind. That takes care of that. And then I'm down to 1 other card. Now it says one other card, which is a different kind from the others. So how many kinds have I already picked from? 2 kinds there, 3 kinds there, so 5 kinds are off the table. How many cards is that? That's 20. So how many cards are left? 32. Well, if you're just picking one more card, you could just go, well, any of those last 32 cards is going to work for me. It's going to be a different kind. You could just say times 32. But if you wanted to be in keeping with what we're doing, you could say, well, if I've already picked 5 of the kinds, so I can't pick any of those kinds, right? So if I pick 5 of them, there's 8 left. I could say, all right, for this last one, there's 8 kinds to choose from. I'm going to pick one. But once I've picked that kind, I'm picking one of those 4 cards. But guess what 8C1 times 4C1 ends up being? 8 times 4, which is 32. And that's how many ways determine the number of ways. And that's not probability, but I didn't ask for probability. And you got to be careful about that. Don't always make every problem probability. All right? On a problem like this, if you put it over probability, because you had done so much right, I would probably just dot you. But a lot of times on the more simple problems, it's kind of like correct numerator, correct denominator. So if you have the denominator in there when you don't need it, you get slashed. This one, you'd probably just get dotted for that. But that would be awful to lose a quarter of your points when you did all of this right. So make sure you're looking at the phrase number of ways or the probability of it. And then if it's probability, how many cards did you end up picking? 13 cards. So you would put it over 52C13 if it was probability. And what do you do if I say in that order?
Permutation.
For everything?
But for the ones that, not the ones that pick the time.
That's right. Not for this, right? Because the order in which I choose the kinds doesn't matter. It's the order in which I pick the cards which would matter, right? Like this is saying, hey, it could be kings, queens, or jacks, or kings or queens, whatever. But then once I start picking kings, it's got to be king, 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 jack, 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 or whatever. So in that case, these would be P, 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 P. But those choosing of the actual kinds would stay C's because the order in which you did that wouldn't matter. Although I've got to be honest, I don't see me doing that, mixing that up on a problem like this. At some point, I got to kind of limit the pay grade that we're operating in, you know?
23B, how do you know when to like put that fraction with like the 6 factorial over, like how do you know when to do that?
Okay, so this one said, find the probability of drawing 2 blue, 3 red, and 1 white. It didn't say in that order, right? But it did say with replacement. So with replacement, what is immediately off the table? Doing it solely with combinations and permutations. So I'm saying, okay, I'm basically going blue, blue, red, 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 not in this order, and 1 white. So I literally got to go one at a time. So what's the probability of getting a blue marble? So I go back up to the beginning, and it says we have 7 blue, 10 red, and 13 white. So the probability of getting a blue would be 7 out of 30, right? So my first blue, there's a 7 in 30 chance of me getting it blue. Now it said for this particular one, with replacement. So if I'm replacing it, I put it back and there's still a 7 out of 30 chance, right? So I can put 7 out of 30 again, or I can square it. And then for the red, there were 10 red marbles. So for the red marbles, I'm going to say that there's a 10 out of 30 chance. Because again, I put it back in there, didn't I? And because I keep putting it back, it's still going to be 10 of the 30 marbles are red. So 10, 30, 10, 30, 10, 30. And then for the white marble, there were 13 white marbles, right? So for the white choice, 13 out of 30. And just one of those. But because I didn't specify in that order, what do I have to do? I have to count up the number of ways to arrange this. Kind of like, how many ways could you arrange the letters in the word Mississippi? So I go, well, there are 6 letters there, but there's 2 B's, 3 R's, and 1 W. And again, you don't have to have 1 W. I just habitually put it in there to show form. And again, that's something you don't have to do if you were able to do it with combinations, because that's already in there with the combination. All right?
I have one from one that we're supposed to do tonight, the probability worksheet. That's not from the book.
So this one right here,
Yes.
what number?
Number 12. I was wondering if like you could just, since you're just finding at least one red, and then you do the 1 minus the probability of no reds.
So much better to do it that way.
But could you just do, instead of finding like all the different ways to do whites and blues, could you just do like 20C4?
Yeah, just do non-reds.
Okay.
Yeah, so right here, the probability, you got two options here. The probability of getting at least one red is either, okay, the probability of getting one red, and since you're picking 4 marbles, that would be what? 3 non-reds. Or you could, or 2 reds, 2 non-reds, or 3 reds, 1 non-red, or 4 reds, and that leaves nothing left. And that's 4 different sets of calculations you'd have to make, which is a lot. The other way of probability of finding at least 1 red is saying 1 minus the probability of no reds. And no reds is the same thing as me saying 4 non-reds. So all I'd have to do is go 1 minus, and non-reds are those, right? So I would say, does it say replacement? No. So I would say, all right, I'm picking, from those 20, I'm picking 4 of them, but there's a total of 27 marbles, and I'm picking 4. And if you wanted to use the individual fractions, I guess you could say on the first non-red, there's a 20 and 27 chance. On the second, a 19 and 26 chance. Third, 18 and 25 chance. Fourth, 17 and 24 chance. And that's me saying non-red, 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 non-red. And then technically you could go 4 factorial over the 4 factorial, but that's really not necessary. And if you really think about writing all this out, that's what that gives me, right? Because 20C4 is like a 20P4 with an extra 4 factorial on the bottom, right? And then 27C4 is like a 27P4 with an extra 4 factorial. Well, those 2 extra 4 factorials cancel. So all you end up with is the first 4 numbers in 20 factorial, bam, 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 and the first 4 numbers in 27 factorial, bam, 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 and the 4 factorials cancel. So either way you do it, I would probably do this. But you can do it this way, it just takes a while. And like I mentioned before, what I like to do on a test is to really kind of set you up to see if you understand a complement. And I'll say something like, if 10 marbles are selected, what's the probability of getting at least 1 white? And you'll be like, are you kidding me? I got to do 1 white and 9 non-whites, or 2 whites and 8 non-whites, or 3 whites and 7 non-whites, or 4 whites. And you end up doing all of these probabilities, but I'm hoping that you'll go, wait a minute, the complement's so much better, right? 1 minus the probability of getting non-whites in there kind of helps my problem a little bit more. So I'm kind of hoping you'll do that, but still providing you a back door, but making the back door uncomfortable. And I don't usually give you like a ton of space to write. There's always, not always, but people come up to my desk. Man, can I get some scratch paper? I'm like, sure. Yeah, man, this problem's so long. It's like, all right. But hopefully that'll be a red flag to you, right? What else?
Number 13.
Same page?
Yep.
Okay, so Biff has a loaded die. You know what a loaded die is? Okay, so a loaded die, unlike a regular die, yeah, it's weighted on a side that causes the probabilities to be unequal. And I don't know if you know this, but I've seen actually a documentary on this, but The die that they use in Vegas, they're very highly regulated. They pick like certain companies, and you have to go in there, and they do random samples of their die, and they do random rolls, and they really make sure that they're creating really perfect die that don't have an advantage one way or the other. But the hope, I mean, people over the years, it's pretty tough now because there's cameras everywhere in Vegas or wherever they have gambling. So they watch stuff, but they look to see if people are like, when they're playing craps, if they're swapping out die. Because it's, you could, if you were really sharp or slick back in the olden days before they had a lot of cameras, to kind of have, the fake die, the loaded die in your hand, and you grab up the rest of them and then throw out the bad ones, and all of a sudden you're getting an advantage because you know how to bet with those die, because you see that they're gonna, and you don't weight the die so obvious if they show up, fours every time. You make it where it's just a slight advantage, because again, Vegas didn't have all those pretty buildings by making it impossible to win. They have those pretty buildings by making it like 51-49 in their favor. It doesn't matter. If enough people go to Vegas and enough people play, and they play long enough, they're going to take 2% or 2% of your money all the time. And if you're stupid, they'll take even more. Like if you don't know how to play blackjack, and you don't know how to make it the best possible scenario for you, and you don't know about the soft, what is it? The soft 17. Yeah, soft 17, aces and sixes. You have a choice whether to stay or to head. Different things like that. If you don't, and when to double down, when to split, if you don't know all that stuff, then they take even a greater percentage. But in a worst case scenario, it's 51-49. Even in the slots. They, like in the really low end slots, like dollar slots, quarter slots, which it's hard to find some of those now. But on the really low end slots, they take a greater percentage. But on the high slots, where you're pulling $10 at a time, they take a smaller percentage, but it doesn't matter. They're taking a smaller percentage, but a greater amount of money is won or lost each hand. They're just taking your money. And then they make a really loud noise when somebody wins to make you think, ooh, that's me, it's coming. So a lot of psychology in there. But anyway, loaded die, evidently the chances of each numbers are different. Now, normally the chance of getting any one face is what? 1 in 6. And on this loaded die, a 1, 2, or 3 each has a 1/6. So that part was normal. But it had a 1/3 chance of getting a 4, and the probability of getting a 5 or 6 is equal. So we actually have to figure out the probability of getting a 5 or a 6. How would we do that? What's the total probability always have to equal? 1, right? Remember we talked earlier, the chance of something occurring impossibly is 0, and if it's certain, it's 1. So the biggest the probability can be 1. So what have I said right here? So I could get a 1, a 2, a 3, a 4, a 5, or 6. And it said a 1, 2, or 3 each has a 1/6 chance. And it says a 4 has a 1/3 chance. And I don't know about these, but it says that they're equal. So I don't know what their percentage is, but the total has to be 1. So I first have to figure out what's the chance of getting a 5 or 6. What's the probability there? So I find a common denominator. I'm going to change this to 2/6. So this is 5/6. So I get 2x equals 1 minus that 5/6. You tracking with me? So that means the probability of getting a 5 or a 6 is 1/12. Y'all with me on that? So now I should be able to do this. It said, what's the probability of rolling 2 4s? So what's the probability of rolling a 4? What did we say? I'll go back to what it originally said. So I want a 4 and a 4, then a 5, 3 2s, and 1 3, and it doesn't specify that order, does it? So what's the probability of getting a 4? Third. So that happens twice. Probability of getting a 5, we found out, was a 12th. Probability of getting a 2 is 1/6. Now why don't we just square those? 2 3 times is 1/6 cubed, and the probability of getting a 3 is also 1/6. But do I do it in that order? No. So 7 factorial over 2 factorial 1 factorial, 3 factorial, 1 factorial, or just 2 factorial, 3 factorial. Right? It's a good old math team question that popped up.
You do 18 on that worksheet.
Sure. Okay, and I think we've done a problem similar to this before. And so it says determine the different ways, how many different ways can 20 students choose to sit in a room with 25 chairs? So one way to do it is to say, okay, let's pretend you walked in here. There's roughly 20 of y'all. Let's just say I had an extra 5 chairs in here. The first thing we got to decide is, well, which chairs are we going to sit in? Now, this is one way to think about it. There's two. The other way is a little easier. You could say, well, there's 25 chairs to sit in. I need to pick 20 of them. And the order that I pick them doesn't really matter. So now I've decided which chairs we're actually going to sit in. Now, once I've decided that, maybe put a big X on the ones that, like, say I did that, and I put a big X on the 5 that nobody's sitting in. I'm like, all right, guys, come in and sit down. Now, how many ways can you guys sit down? What would that be? But the order in which you sit down might affect the outcome, right? Could it? The order in which you pick them doesn't. Right? Like if I pick 20 chairs out of here, and then I put X's on the 5 that you're not sitting in, do you know which order I picked? No, so that part doesn't matter. But you actually sitting might have an effect on the outcome. Like I have one of my classes, I've noticed over the year, and it's really made a difference, that people sitting in the back were just bombing. So I moved them all to the front row, and now they're all making B's. I don't know what it is. It's not like they were sleeping before, but it's working. So I moved. That's not what I did in here. So I don't feel better. But I did that in this class, and like all these C's and D's turned into B's just by putting them up front. So I put the guys that I knew needed no help from me in the very back, and it's worked out well. So the order can have an effect on the outcome. So you go in and say, all right, well, of the 20 students, 20 on this, and what do you get? 25 factorial. Oh, you don't have to, but what do you get? 25 factorial over 5 factorial, 20 factorial, right? Times a what? 20 factorial over a 0 factorial, which is just a 1. And what does that leave me with? It leaves me with 25 factorial over 5 factorial. What's 25 factorial the same over 5 factorial the same as? 25p20. So I could have just said, hey, there's 25 chairs. I'm going to pick 20 of them. And the order matters of the ones I pick, because I'm going to be arranging students possibly in different ways, and it might affect the outcome. So you can see the math of this and the math of this still ends up being the same thing. Yeah.
In what case would you use 25C20 just by itself for a question like this?
If I told you, like, maybe if I was thinking about a college class and truly the order, I'm trying to think of something, and truly you knew the order that in which somebody sat had absolutely no effect. I'd probably avoid a question like this. Well, maybe I wouldn't. But if you could argue somehow that the people sitting there truly had no effect, maybe like this, parking spaces. Like say there's 20, how many ways can 20 people find?
If you said like, how many ways can I choose 20 students to sit in a room with 25 chairs? Would that be 25C20?
Could I choose the students to sit in the chairs? It could be, but again, you would have to be able, without reason, without any worries, know that, hey, the way that in which I arrange those 20 truly has no effect on the outcome. Like if I'm talking about picking students in chairs, you've been in school long enough. We're not talking about just this class where, it's relatively quiet and you guys behave well. It doesn't really matter where I sit you. But like go back 2 or 3 years, right? And you put the wrong two people together, heck, even a couple years ago, you put the wrong two people together in middle school, you got chaos. Isn't that right?
Okay.
I got a 10th grade kid and he's like a model citizen in my class. But every story I've heard on the planet is like just last year and every year before. They're like, the other class can't even believe he's a model citizen. I'm like, dude's awesome in here. Makes A's and B's, always contributes to class, always does something. They're like, what? Like they can't even believe it. He was just a constant source of anxiety and chaos wherever he was in the room, evidently. But not in here, he's great. I mean, he really adds to the class. So yeah, I mean, in a lot of classes, the way in which you order them. But yes, to your argument, if there was a way you could write it and suggest that, hey, the order doesn't matter at all. Kind of like when you pick cards, the order that you pick those cards doesn't matter at all, right? If you pick 20 from the 25, but if you can argue that, hey, the 20 from the 25, when I put them out there, yeah, the order could have an effect on the outcome. And if there is any doubt, I mean, you come up to my desk. Like if it's something that we've done 100 times, you probably shouldn't, because I may say we've done this 100 times. But if it's something that's unique on the test and you're like, hey, I'm interpreting it this way. Is that the way you want it interpreted? I might go, no, I'm suggesting this. And I can clear up any ambiguity that way. What else you got? Anyone? What do you think? What are you feeling? Good? Numb? Comatose?
Chilling.
Just chilling? All right. Last call. I mean, not really. I don't want dead space on the video. Anybody from home got a question? Should be able to hear you. Sid, Pascal, what do you think, man?
I'm feeling pretty good, Mr. Hurry.
All right.
Yeah.
Pascal?
Type in the chat box.
He's taking a little nap. We know. All right. We'll see you guys. All right. Well, keep working. You want to knock it out? I got some stuff to hand back to you, so you'll have everything. So because this one, I specified it had to be John.
Uh,
So because John was one of those people, there's really only one way to put that dude in the chair. But on this one, I didn't specify who it had to be, so it could be any one of the seven, so I had 7 options for that first choice. Whereas this one, I was forced to just have one.
Okay.
Yeah. Sure.
I think I forgot.